Hello viewers, welcome to K Diagnostics, Dio here. Today we have a 2007 Chevrolet Impala with a 3.5 liter. The complaint on this vehicle is the check engine light remains on while the engine is running. So the first thing we're going to do is we're going to confirm the customer's complaint. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. After we retrieve the trouble codes, then we will know what directions we're going to go so we can fix whatever that's causing the check engine light to remain on. So now let's go inside the vehicle and confirm the customer's complaint. Alright guys, I'm going to start the engine so we can confirm the customer's complaint. Let's see if the check engine light will remain on while the engine is running. So right there, as you can hear, the engine is running and the check engine light remained on. So right there, check engine light is on and the engine is running. So customer's complaint confirmed. The customer is complaining about this light that's remaining on while the engine is running. So we have confirmed the customer's complaint. So now I'm going to turn off the engine. So I'm going to turn the key to the on position. I'm going to connect the scan tool to the vehicle and then I'll bring you guys back up so we can see what kind of trouble codes we have in memory. So I'll get the scan tool connected and then I'll bring you guys back up. Alright, so I got the scan tool connected. So now we're going to scan it for some trouble codes. So right there, the scan tool has identified the car. So let's click OK. So we have one trouble code in the engine computer. P0446. Okay, we don't have any trouble codes in the transmission control module, no codes in the airbag, no codes in the BCM. We have two trouble codes in the keyless entry control module. Okay, so right over here on the generic side of the tool we also have the same code, P0446. Evap system vent control circuit. Okay, so this is good to know. Now we're gonna focus on this trouble code, this P0446 trouble code, because this is what's causing the check engine light to remain on while the engine is running. But we're also gonna notify the customer about these other codes, and if the customer wants us to fix these trouble codes, we will take care of these at a later time. So right now we're going to focus on this P0446 trouble code. And right over here on the OE side of the scan tool, and it says evaporative emission evap vent system performance. Current DTC test failed since DTC clear. History DTC test not passed since power up. Warning indicator requested. So the description of this trouble code tells me that we have a problem in the Evap system and we most likely have a problem with our vent solenoid. So now what we're going to do is we're going to go straight to the engine control module. So let's click on engine, and this one has an air pump, so we're going to click on with air pump. So let's just double check this trouble code one more time. So right there we have the same trouble code here, so that's good. So now let's back out of here and see if we have a problem, because this trouble code can be caused by, a defective vent solenoid will cause this trouble code to be set, and a bad purge solenoid can also cause this. If you have a bad solenoid, a purge solenoid that's not opening, it can also throw this trouble code. You may have a purge valve code, but sometimes I've seen a bad purge valve triggering a vent solenoid code. So at this point we just have to check the Evap system. Before we do anything else, I want to go to functional test, go to output controls. So let's find the vent solenoid on this list and see if we can turn it on and off. And then we will do the evap purge / seal test. So over here it says Evap vent solenoid close and open. So let's click on that. This should allow us to open and close the vent solenoid from the scan tool. So right now, if I click on close, we should hear the solenoid clicking in the back. These solenoids are pretty loud. Once I close it, you should hear it. And this vent solenoid is a normally open solenoid. So when it's in the open position, it should be venting. So it's gonna allow air to go to the charcoal canister. And over here, we have a data pid that's saying venting right now. When I close it, it should say closed over here. And we should be able to hear it click from the back. So hopefully it's gonna be loud enough. So right there, close, open. So our PID is definitely changing. So we're going from venting to not venting. So right there, it's venting. And right there, it's no longer venting. It says not venting. So that means the solenoid is being opened and closed. So I don't know if you can hear that, but I hear the solenoid clicking from the back. So that basically means that there is power at the solenoid, and the control is definitely there coming from the computer. So this tells me that the wiring of the solenoid is good because I can hear the solenoid click. But a solenoid clicking doesn't mean the solenoid is good, okay? If you have a solenoid that clicks, doesn't always mean the solenoid is good, because you can have a solenoid that clicks, but there's no actual movement of the valve inside the little solenoid, okay? What we have to do is we have to make sure that this solenoid is really closing and opening. So now at this point, what we're gonna do is we're gonna do a Evap seal test, okay? We're gonna send vacuum in the Evap system, and then we're gonna close the purge valve and the vent valve to see if there will be vacuum in the tank. And we're gonna see that with the data pid of the fuel tank pressure, okay? We should have a vacuum inside tank, and that's gonna show us with negative numbers on the data pid of the fuel tank pressure sensor, okay? So now let's back out of here. Again, like I said, a solenoid clicking doesn't mean it's good, okay? We're still gonna go back to it and make sure it's good. Actually, this Evap purge / seal test will show us, or will tell us, if the purge solenoid is good. Let's click on continue. So we're gonna have to start the engine to do this test. Actually, before we start the engine, I'm gonna customize this list. I don't wanna look at all these data pids. I just wanna look at the fuel tank pressure sensor data pid, the purge solenoid data pid, and then the vent status, vent solenoid status, and then the tank pressure sensor pid, the voltage data pid, and then purge solenoid status, okay, vent command. So that should be it. These are the only data pids that I want to look at right now. So let's list this. So now I'm gonna start the engine. So we're gonna watch this speed over here, this fuel tank pressure data pid. So let me graph this. Okay, so we're gonna watch this graph. So right now, with the engine running and the purge solenoid at 0%, we are reading 5.96 inches of mercury, okay, on the fuel tank pressure data pid. So, and then the voltage of the pressure tank sensor, the tank pressure sensor, is 0.2 volts, okay? And our vent solenoid is not venting, is closed right now. So what I'm gonna do now, I'm gonna start to open the purge solenoid. So what this will do is it's gonna allow vacuum to enter the Evap system. Once vacuum starts to enter the Evap system, this tank pressure voltage over here should change, okay? and the pressure here inside the tank should go in a vacuum because we're sending vacuum in the evap system and then eventually inside the tank. So now let's open the purge solenoid. I can kind of hear the engine speed change. So we are at 70%, and what do you notice here? The fuel tank pressure does not change. Okay, I can actually hear a hissing sound coming from the back. So let's decrease this percentage, otherwise it's gonna kick us out. So nothing is happening on the pressure sensor over here, the fuel tank pressure sensor data pid. Let's graph the voltage data pid also. So these two data parameters are not moving at all. So let's increase that again. So we're gonna open the purge valve one more time. Let's go all the way up to 100%. So this here should have changed because we are sending vacuum into the fuel tank. And as you can see, there's no change at all. Okay, so this is why we have a trouble code set for the vent system, because there's a problem in this evap system. Okay, and our vent solenoid is saying not venting, but the fuel tank pressure is not moving. I mean, there was a little bit of a change over here, so that wasn't much. It just went from 5.97 down to 5.96, so that's nothing. So basically there is no change. Okay, the computer is not seeing this vacuum that's being applied into the fuel tank. So I mean, this is why it probably didn't kick us out, because the computer is not seeing this vacuum. So let's close this purge valve. I'm gonna turn off the engine. So let's talk about what's going on with this. Well, this can be caused by a couple of things. So as you guys saw with the engine running, we opened the purge solenoid while the vent solenoid was closed. So there was nothing happening on the data pid of the fuel tank pressure sensor. Okay, so basically the way this system works is the computer opens the purge valve. It allows vacuum to get inside the evap system, and then it closes the back door, which is the vent solenoid, and then it also closes the purge valve. Actually, we are the ones here opening and closing the purge valve as we're doing this test. So if you close the purge valve, well, you will have vacuum trapped in the evap system. So once you have this vacuum trapped in the evap system, the fuel tank pressure sensor is going to see that vacuum. The data pid over here, the pressure inside the tank is going to drop. Okay, that's how the computer knows that the evap system is functioning. If the computer doesn't see a change on this fuel tank pressure sensor, then it triggers the code. Now, this can be caused by either a defective purge solenoid, because if we come from the front going back, if we have a purge solenoid that's not opening, this trouble code can be set. You can have an open or a break in the evap system. So if one of the lines is cracked or leaking, so the vacuum getting inside the evap system, instead of going to the tank, it may be leaking out from somewhere, and that's not going to drop the pressure inside the fuel tank, and the computer is going to trigger the code because the computer is looking at a pressure change inside the fuel tank, and it picks up that pressure change in the fuel tank by looking at the data pid coming from the fuel tank pressure sensor. If the fuel tank pressure sensor data pid doesn't change, the computer triggers that code. Now, the other thing would be a defective vent solenoid. If you have a vent solenoid that's stuck open, instead of closing, it could be saying over here not venting, but if it's still open, so if it's stuck open, so the vacuum we're gonna send into the evap system is just gonna escape out of the vent solenoid. Okay, so now what we need to do is let's go under the hood and make sure our purge solenoid is working. we're gonna disconnect it and command it on. We have to see vacuum on the other side of the purge solenoid. If we see vacuum there, then we're gonna raise up the vehicle and go to the back of the vehicle around the fuel tank area. We're gonna check the vent solenoid, and then we'll go from there. So we have to figure out why this fuel tank pressure sensor data pid is not changing. And then the last thing would be a defective fuel tank pressure sensor. If you have a defective fuel tank pressure sensor itself, the vent solenoid could be good, the purge solenoid could be good, the tubing of the Evap system could also be good. But if you have a fuel tank pressure sensor that's bad and not reporting the pressure change inside the fuel tank to the computer, this trouble code will also be set. So now let's go under the hood and check the purge valve first. So let's go under the hood. Alright guys, so we're here under the hood. We're gonna use the gauge on this vacuum pump to check for vacuum on the other side of the purge solenoid. So I'm gonna remove the engine cover. So the purge solenoid should be somewhere over here. So let's put this back first. So here is the purge solenoid. Okay, so I'm going to disconnect this tube. So right there, here is our purge solenoid. So we're gonna connect this hand vacuum pump to the purge solenoid. So we're gonna connect this over here. So with the engine running and the purge solenoid off, there shouldn't be vacuum on this side of the purge valve, okay? So there should only be vacuum over here when we command the purge valve on. So if we don't turn it on, there shouldn't be vacuum going to this vacuum gauge. We will only have vacuum going to the vacuum gauge when we start to turn on this purge solenoid with the scan tool. So now I'm gonna go inside the vehicle and start the engine. Alright, so I got the engine running. Let's check this vacuum gauge. As you can see, we got 0 over here, so there's no vacuum on the other side of the purge valve. So that's good. So now we're gonna use our scan tool to open up the purge valve. So I'm gonna start opening the purge valve. So we opened the purge valve up to 40%. Now let's watch our vacuum gauge. So right there, as you can see, we're reading vacuum on this gauge, okay? So there's vacuum there. So now when I turn this, when I start to close the purge valve, that vacuum over there should drop. Okay? I mean, it's not gonna drop because it's trapped between the gauge and the purge solenoid, so I'm gonna have to release it. But as you can see, I released the vacuum. Our gauge is showing 0 right now. So let's open the purge valve once again. So right there, our gauge just climbed up. I don't know if you saw that, but let me take this down again. I'm gonna put this in the shot. So watch that. So I'm going to turn on the, so I'm going to open the purge solenoid again. So right there, watch the gauge on the vacuum gauge over there. You see how it went up? So our purge solenoid is working. Okay, so that's good. Purge solenoid is good. Let's release this. Okay, so purge solenoid is fine. I'm gonna disconnect the purge solenoid. We can reconnect the Evap tube on this side of the purge solenoid. So that's good. Now, we could have a problem between this tube over here back to the tank, because we can have a cracked tube or a hole in the tube. So now what we need to do with the engine running, we're gonna go to the back of the vehicle around the fuel tank, and we're gonna inspect that area. And while we inspect that area, I'm gonna show you a test you can do to test the vent solenoid, to see if the vent solenoid is stuck open, okay? So over here under the hood, the tubes for the evap system look good. Okay, so I'm gonna raise up the vehicle. We're gonna get the vehicle up in the air, and then we will test the vent solenoid to see if the vent solenoid is stuck open. So now I'm gonna lift up the vehicle. Alright guys, so we are here under the vehicle. The engine is still running. We have a couple tubes going to the back of the vehicle. We have two big ones and two small ones. The small ones are the brake lines, and then the two big ones are, one is the fuel delivery line to the engine, and then the other one is the evap tube. So we're gonna follow these tubes to the back of the vehicle. So here are the tubes. This is the fuel tank. I can hear the pump running inside the fuel tank. And then our vent solenoid is somewhere up here. So right up there. So here is the vent solenoid, okay? And when I was turning the vent solenoid on and off, I could hear the vent solenoid clicking. So that told me that the wiring of the vent solenoid is good. But if you follow this tube over here, this tube goes to the fuel tank, okay? This tube over here from the vent solenoid down to the tank, okay? So over here is a plastic tube. So this tube over here is plastic, but over here it is rubber, okay? So now what we're gonna do is we're gonna test this vent solenoid. So when we're doing a evap seal test, the fuel tank pressure sensor data pid is not changing, which is telling me that the pressure is not changing inside the fuel tank. So it means the vacuum coming from the engine is either not making it to the tank, or the pressure sensor on the tank is basically lying to us, or this vent solenoid over here is sticking open. If you have this solenoid stuck open, the pressure is not going to change inside the tank, okay? So that's what we need to find out. So now what we're going to do is we're going to close this manually. So you close this manually by pinching this tube over here. We're going to get a vice grip and pinch this. By pinching this, we're going to block all the fuel vapors inside the tank. So the fuel vapors, or vacuum in this case, we're using vacuum to test the evap system. So if we pinch this, we won't have enough vacuum going to the vent solenoid, okay? If this is stuck open, it's gonna let all the vacuum leak out. So we're gonna pinch this, okay, to block the vacuum inside the tank. So after pinching this, if our fuel tank pressure sensor data pid changes, that will tell me that our issue is 100% the vent solenoid. So that way I will know that the vent solenoid is stuck open. So I'm gonna get a vice grip, we're gonna pinch this, and then we're gonna do our evap seal / purge test again to see if our data pid of the fuel tank pressure sensor is gonna change. So I'll get a vice grip, we're gonna pinch this, and then we'll see what happens. So alright guys, so we're gonna use these vice grips over here to pinch this line, okay, the line that goes to the vent solenoid. Now before we pinch that, I want to look at the data pid on the scan tool. So the scan tool is still connected to the vehicle. So right there, right now with this line not pinched, our fuel tank pressure sensor is reading 5.96 inches of mercury, and then the voltage is 0.2 volt, and this is with the purge valve at 0%. So now what I'm going to do is I am going to open the purge valve just like we just did. I'm opening the purge valve. The engine RPM changed a little bit, but these data pids over here did not change, okay? Well, the engine RPM just changed because we are basically creating a vacuum, a vacuum leak. So as you can see, the fuel tank pressure sensor data pid didn't change, and the voltage over here didn't change either, okay? And we are at 80% of the purge valve, okay? 80% opening. So let's go down to 0. Okay, so basically there is no pressure change inside the fuel tank. So let's go back over here. So we're gonna use this guy to pinch this. Alright, so we just pinched the tube that goes to the vent solenoid. So now we're gonna use the scan tool again to open the purge solenoid. Once we open the purge solenoid, there should be a pressure change in the fuel tank. If the pressure inside the fuel tank changes, that will tell me that our vent solenoid is stuck open. And after that, the issue will just be replacing the vent solenoid, and this should be good to go. So now let's look at the scan tool. Alright, so here's our scan tool. Now we're gonna open the purge solenoid. So right there, actually there's vacuum coming to the tank because there's a noise over here. Yeah, there's actually a noise up there on the filler neck tube. So there's definitely vacuum going to the fuel tank. But our pressure sensor data pid didn't change. Our fuel tank pressure sensor data pid did not change. So we might be dealing with a defective fuel tank pressure sensor. Okay, so yeah, there's definitely vacuum over here. Do you hear that noise up there? There's definitely a problem. So let's look at the scan tool again. So here's our scan tool. Our data pid of the fuel tank pressure didn't change. So let's drop this down to 0. So let's close the purge valve. After closing the purge valve, the noise over here has stopped. So let's check this out. So after closing the purge valve, the noise up here has stopped. So this tells me that there's vacuum coming all the way up to this point. The problem is the sensor itself. So now we have to test the sensor. Okay, let's see why the sensor is not changing, why the data pid of the sensor is not changing. Because the signal of the sensor, the voltage on the signal wire of the sensor is stuck at 0.2 volts. So I believe there is a connector over here. There's an electrical connector right there. You see that? So this electrical connector goes above the fuel tank. So this electrical connector has got wires for the fuel pump, the fuel level sensor, and then the fuel tank pressure sensor. Okay, so we're gonna look at the wiring diagram and see which wires are the wires for the fuel tank pressure sensor. We're gonna back probe those 3 wires for the fuel tank pressure sensor. So one wire is gonna be a ground wire, the other one will be the 5-volt reference, and then the third wire is going to be the signal wire. Okay, so we're gonna back probe all these wires, and then we will send vacuum inside the tank to see if the pressure change inside the fuel tank is gonna affect the voltage on the signal wire of the fuel tank pressure sensor. So I am going to look up the wiring diagram, and then I will bring you guys back up so that we can back probe these wires. The fuel tank pressure sensor has 3 wires. Like I said, there is a 10 wire, which is it looks like the ground wire. Okay, there's a gray wire, which is gonna be the 5-volt supply wire, and then there's a dark green wire, which is gonna be the signal wire. Okay, so we're gonna go to the wiring harness on the vehicle side and back probe these 3 wires so we can test the fuel tank pressure sensor. Okay, I'm gonna show you these wires on the wiring harness, and then we're gonna back probe them we're gonna do the same test we just did really fast. We're gonna close the vent solenoid. We're gonna open the purge solenoid and close it to see if the voltage on the signal wire over here is gonna change. If the voltage doesn't change, that will tell me that this fuel tank pressure sensor is defective. And then at that point, we're gonna have to lower the tank so we can get this fuel tank pressure sensor replaced. Okay, so I'm gonna show you these wires on the vehicle and then I'll back probe them. All right, so there are the wires of the fuel tank pressure sensor on the wiring harness. So there is the green wire, the tan wire, and then the gray wire. I hope you can see those wires. So let me zoom you guys in so you can see them. Okay, so right there. So there is the green wire, the tan wire, and then the gray wire. So these three wires over here, these wires are the wires for the fuel tank pressure sensor. I will back probe these wires. We're gonna use a lab scope to monitor the voltage on these three wires, okay? So I will back probe these wires and then I'll bring you guys back up. All right guys, so we got the fuel tank pressure sensor wires back probed. So now let's look at the lab scope and see what kind of voltages we're gonna see on the signal wire of the fuel tank pressure sensor. So now let's look at the lab scope. All right, so we back probed these three wires coming from the fuel tank pressure sensor. So now we're gonna hit the home tab. We're gonna look at the scan tool, okay? We have to be able to use our bidirectional controls on the scan tool and also look at the lab scope at the same time. So we're gonna do that by going to the guided component test. So let's go to engine. So at this point we can pick any sensor we want, okay? Let's just do Evap system. Let's do fuel tank pressure sensor. Actually that's the one we're testing. So let's hit view mirror. Okay, so we're gonna click on, actually let's turn on the other channels first. So we're gonna be using 3 channels. We're gonna monitor the voltage on the signal wire, the 5-volt reference, and the ground wire. So over here all our channels are turned on. Okay, so let's see if we can see some G0 numbers over here. So right over here it looks like the green trace is showing 4.96 volts, so this is our 5-volt reference. And then the blue trace is showing 0.12. It's kind of fluctuating between 0.13 and 0.9. And then the yellow trace is kind of going between 0.14 and 0.4. So the yellow trace is going to be our signal wire. The green trace is going to be our 5-volt reference. And then, and then the blue trace is going to be our sensor ground. Okay, so let's click on mirror. Okay, so now we're gonna back out and go to the scan tool. The vent solenoid is now venting. Now we're gonna start opening the purge solenoid. Before we do that, we're gonna bring up our lab scope here on the screen. Okay, so we have our lab scope over here. Now I'm gonna start opening the purge solenoid. I just heard the engine RPM change. So as you can see, the yellow trace is actually our signal. Okay, the signal coming from the sensor. I'm sorry. This is the yellow trace is the signal because the yellow trace is on the dark green wire, which is the sensor signal wire. Okay, and over here we are at 70% purge valve, the opening percentage, and we are still reading 0.12, so it's kind of fluctuating, 0.13, 0.4 on the fuel tank pressure sensor. and our 5-volt reference didn't change. I mean, we have 4.94. It's kind of fluctuating, and then our ground is also good. So this is telling me that the sensor, let's close this again. So we just closed the purge solenoid. Let's bring up the scope. So look at these voltages. So the purge solenoid is closed. Okay, we're at 0%, and look at the signal. Okay, just look at the yellow trace. So our signal is going between 0.07, 0.014. It's fluctuating. Okay, and this is with the purge solenoid closed. So now we're going to open the purge solenoid. So I can hear the hissing sound coming from the tank. So that's vacuum inside the tank. So let's bring up our lab scope. Just focus on the yellow trace, guys. As you can see, the yellow trace is doing the same thing. Okay, so that voltage should have changed. As you can see, we are reading 0.20 on the max. So this is what we saw on the scan tool. Actually, the data pid is over here. This is the data pid. You see this data pid over here? Tank pressure voltage 0.2. Well, it is the 0.2 over here, the max. This is what the scan tool is showing us. Okay, so this tells me that the wiring is good. Okay, the wiring of the sensor is good. The computer is definitely showing this 0.2, which we have on the lab scope right over here, the max on the yellow trace. So this tells me that the sensor is bad. The fuel tank pressure sensor is defective. Okay, so we're gonna have to lower the tank and get this sensor replaced. Our ground is good. Our 5-volt reference is there, but the signal is not looking right. Okay, so defective fuel tank pressure sensor. I'm gonna turn off the engine. We're gonna lower the fuel tank just a little bit. I don't want to take the fuel tank out completely. We're gonna lower the tank, and then we're gonna get this fuel tank pressure sensor replaced. Once we get a fuel tank pressure sensor replaced, this problem will be fixed. So once we replace the sensor, so right over here, we are at 100%. You know why it's not kicking us out? Right now at 100%, it should just stay at 100% for a few seconds, and then it would kick us out. It's not kicking us out because Pure is not seeing a pressure change inside the tank. So as you saw, this here didn't change. We are at 80% opening of the purge valve, and over here fuel tank pressure sensor voltage is 0.2, and we have the same 0.2 over here on the lab scope. Okay, so let's back out of here. Okay, so I'm going to disconnect everything. I'm going to turn off the car. We're going to lower the tank to get this fuel tank pressure sensor replaced. So now let's do that. Alright guys, so I have dropped the tank. Here is the fuel tank pressure sensor. This is the Evap charcoal canister, and this is the fuel pump assembly. Okay, so this guy over here is what we have to replace. Okay, this is the fuel tank pressure sensor that's not working. So we're gonna have to pop it out and disconnect the electrical connector, and then we're gonna replace it with this new one. Okay, so I ordered a new fuel tank pressure sensor, and here's the part number. Okay, so this is the part number for the new fuel tank pressure sensor. Okay, so we're gonna get this one removed so we can install this, and then after that we're gonna reinstall the fuel tank. So now let's get the fuel tank pressure sensor replaced. Alright, so I'm gonna disconnect the sensor first. So the sensor is disconnected. Now we're gonna pry the sensor out. So here comes the old sensor. So here it is. We're gonna replace this. So we're gonna get this one out of the box. So here is the new one. So this is what we're gonna install. Alright, so now I'm gonna install the new fuel tank pressure sensor. So it just pops in, guys, once you get it lined up, and then we're just gonna pry it in. So right there, just like that. So now we're gonna inspect the terminals of the electrical connector of the fuel tank pressure sensor. So the terminals look good. So now we're gonna reconnect the fuel tank pressure sensor. So right there, the fuel tank pressure sensor is connected. And also, I don't know if I mentioned this, I had to empty the fuel tank. The fuel tank was almost full, so I had to pump all the fuel out of the tank before I dropped it. Okay, so you gotta make sure when you do this job, drain the tank first before you lower it. Okay, so the new fuel tank pressure sensor has been installed. So now I'm gonna lower the vehicle so I can reinstall the fuel tank on the vehicle. So I'm gonna turn off the camera. I'll bring you guys back up once I put the fuel tank on the vehicle, once the fuel tank is all reinstalled, and then we're gonna put gas in the tank. I'm gonna start the vehicle so we can double check our repair. So I'll bring you guys back up once I have reinstalled the fuel tank. Alright guys, so I have reinstalled the fuel tank. Everything is back together. The vapor line is installed. The filler neck tube is also reinstalled. I have reconnected the electrical connector of the fuel pump and the fuel tank pressure sensor. The fuel tank straps are tightened. So everything is back together. I'm gonna lower the vehicle so we can go inside the car and start it. Once we start it, we're gonna do the Evap purge/seal test to see if the fuel tank pressure sensor data PID is gonna drop when we do the Evap purge/seal test with the scan tool. So now let's go inside the vehicle and verify our repair. So now we're gonna start the engine so that we can verify our repair. I did put fuel inside the fuel tank, so the fuel tank is not empty. So I'm gonna cycle the key a couple times to prime the fuel system. I can hear the fuel pump running in the back. So now let's start the engine. Awesome, it started. Okay, so now what we need to do is we have to bring up the scan tool over here and do our Evap purge/seal test. Okay, so let's do this while the engine is running. It should be able to allow us to do that. Okay, so we're gonna watch this one. Right off the bat, there's a huge difference. Remember before, the fuel tank pressure was I think it was 5.94 or 95 inches of mercury. So right now, with the fuel tank pressure sensor replaced, right now we're reading 0.05 inches of mercury. So right off the bat, there's a huge difference. This is fixed, guys. I can already tell it's fixed. And our voltage, our fuel tank pressure sensor voltage is reading 1.5 volts. Remember before it was stuck at 0.2 volts. Okay, so now let's open the purge valve and watch this. Okay, this voltage over here should increase and this over here will decrease. We will go into a vacuum. We will see negative numbers here as we open the purge valve, and then the voltage over here should increase. So watch this. Do you see that? Do you see this decrease? And we have negative numbers over here. Yeah, this is working now. So now we're gonna close it So right there. And watch this. You see how this one went up, the voltage? You know, the voltage goes up, and then we went into a vacuum over here. This is fixed, guys. So I'm pretty sure this trouble code is now gonna come back on. As you can see right now, the check engine light is off. Okay, so I'm pretty sure with the data that we have right now, this vehicle is fixed. I mean, as you can see, there's a huge difference, okay, on the voltage level that we have over here, you know. So before it was stuck at 0.2 volts. So right now we have 2.3 volts, and the pressure over here will still have vacuum inside the fuel tank. This is an indication of a good evap system. This system is sealed and it's good. So let's back out of here. So once we backed out, it opened the vent solenoid. I heard the vent solenoid open, so that vacuum is gonna bleed off. Okay, so let's try this one more time, just one last time before we wrap up this video. So let's graph these. So right now at idle, with the vent solenoid open, okay, as you can see, well, no, it's not venting, I'm sorry, it's not venting because we're doing the test. The vent solenoid is closed, okay, the purge solenoid is at 0%. Right now the pressure inside the tank, I mean, we still have vacuum. Wow, this is vacuum. There's still vacuum, a little bit of vacuum trapped inside the fuel tank from the previous test we just did. Okay, now watch this voltage. As I start to open the purge solenoid, this voltage will start increasing. So you see right there, it kicked us out. Did you see that? And before, it wasn't even doing this. I went all the way up to 100%. I mean the opening of the purge solenoid. So I opened it all the way to 100% and it kicked us out. Okay, because now the computer is seeing the vacuum inside the tank. So the computer knows that there's a lot of vacuum in the tank because it's watching the signal coming from the fuel tank pressure sensor. So it sees that increase in voltage. That's how the computer knows that there is enough vacuum inside the fuel tank, and then if it passes a certain threshold, then it kicks you out. Okay, but remember, before we went all the way up to 100, it wasn't doing that. So I'm gonna turn off the engine. So right now it's venting now. Okay, the vent solenoid has opened, so it's gonna bleed off this vacuum really fast. Watch, we still have negative numbers, and then it's gonna go to positive numbers now, and then the voltage over here is gonna decrease. You see that? Yeah. So that's good, guys. This is awesome. This is fixed. The evap system was basically good. The evap system didn't have a problem. The purge solenoid was good. The vent solenoid was good. The tubing of the evap system was still good. And the problem was a defective fuel tank pressure sensor. Okay, so I am going to show you a evap system that I just drew on a piece of paper in case you still have questions about what I did. After showing you this little schematic, I'm gonna explain a little bit what I did on that schematic, and then we will wrap up this video. Alright guys, so I drew the evap system that we worked on a piece of paper. So the evap system allows fuel vapors to leave the fuel tank and get to the engine so they can get burnt while the engine is running. So we have the fuel tank, the charcoal canister, the purge valve, the engine, the ECM, and the vent solenoid. Okay, so the way this works is when the computer checks this system, the way it does that, it closes the vent solenoid, it opens the purge solenoid, it then allows if you open this purge solenoid and you close the vent solenoid, you are gonna allow vacuum, engine vacuum from the intake to travel from the intake through the purge valve and through this tube and through the canister and into the tank, okay, and up to this tube over here. But since the vent solenoid is closed, you will have vacuum inside the tank. If you have vacuum inside the tank, there will be a pressure change in the tank. So the fuel tank pressure sensor is going to pick that up and notify the ECM about the pressure change in the fuel tank. And then the ECM is going to watch that pressure change for a certain amount of time. If that pressure doesn't change for a certain amount of time, that's how the ECM knows that the Evap system is sealed and everything is good to go. Okay, so if that doesn't happen, then the ECM triggers the code that we just had. Okay, so basically this over here is a normally closed solenoid, the purge valve, and then the vent valve is a normally open solenoid. So there's power coming to it on one wire, and then the computer controls the ground on this control wire. Same thing with the vent solenoid, there's power on one wire, and then there's ground controlled by the PCM on the other wire. Okay, so when I did the test we were doing, I did the Evap purge/seal test. So what that does is it closes the vent solenoid, and then you open the purge solenoid for a certain percentage, and then you close it to allow vacuum to enter the Evap system. And once you close this, so if you open this and close it while this vent solenoid is closed, you're gonna trap vacuum in the Evap system, because these are tubes that are sealed. So you have a front door here and a back door over here. And then if you close this and then you open this, let's say you open this up to 20% or 30%, and then you close it, so you have vacuum trapped in here. Once you have vacuum trapped, the pressure is going to change in the tank. Okay, so while I was doing that, nothing was happening on the data pid of the fuel tank pressure sensor on the scan tool. Okay, the data pid of the fuel tank pressure sensor was reading 0.2 volts, and then on the pressure we were reading 5.95 inches of mercury, which told me that something was wrong, because if the vent solenoid open or closed, this data pid over here wasn't changing. Okay, so the computer would look at that and see no change, then it would trigger the trouble code that we had. So what I did was I went to the purge valve first, because if you have a purge valve that's not working, that's not allowing vacuum to enter the Evap system, it's going to trigger the same code. Okay, because there won't be any pressure change in the tank. So we commanded the purge solenoid to open. It opened, and then we had vacuum over here. So this told me that the purge solenoid was good. The next thing we did, I opened the vent solenoid on and off with the scan tool. The next thing I did, I came to this tube over here. I used a vice grip. We pinched it. Once we pinched it, we opened the purge valve. The pressure change over here was changing. I mean, we had vacuum in the tank, but our pressure sensor, our fuel tank pressure sensor, was still showing 0.2 volts on the signal wire. The next thing I did, we came to the wires, we tested the wires. We had 5 volt, ground, and then a signal. I mean, it's a pressure sensor. Pressure sensors have 3 wires. You have a 5 volt reference, a ground wire, and then a signal wire. Okay, and when we did the test at the wiring with the lab scope, we had the same voltage that we saw on the scan tool, 0.2 volts. So at that point, that told me that the fuel tank pressure sensor was bad. And when we closed the vent solenoid and opened the purge solenoid, I heard a hissing sound around the fuel tank. So that told me that there was vacuum making it to the fuel tank. So the tubing and everything else on the Evap system was good, but the problem was a defective fuel tank pressure sensor. Okay, so I hope this answers some of the questions that you might have. So now let's go back inside the vehicle and wrap up this video. So right there, as you can see, everything looks good. Check engine light is off. So this is fixed, this is good to go. So now I'm gonna turn off the engine. Alright guys, so I'm gonna leave it right over here guys. This is how you test an Evap system. So I hope you like this video. If you do like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If you have any comments, questions, criticism, leave them in the comment box. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. Thanks for watching guys. See you next time.